the arrow. You can see the arrow there, right? Have people received it? We want to have a section front view. How big the drawing is. We can do it in third angle, right? Everything is the same. It's just the order of the views that will change. Is that okay with you? Or you still want us to work with first angle? First angle, third angle. Third angle. So we have that object. Someone tell me the total length. Even this one is simple. Everything is there. There's 160. Our width is 100. And our height, maybe the height is what will throw people off. What's our height? If you have calculators, you can use them. People make mistakes in drawing because of simple addition. But the numbers are supposed to add 30, 42, and 12. What does that give you? 30 plus 42 plus 12. 54 plus 30. I'm simplifying for you. See, no one doesn't want to tell me the answer. You confirm if there are people who can. 94 is what I think the answer should be. 12 plus 42 gives us 54. 54 plus 30 gives me 94. 84 or 94? Eh? 84. 54 plus 30. 84. Okay, it's good people are following. You've confirmed this, your calculator. There's no need, eh? So, in this drawing, you see the trick is you knowing that R30 gives you the top part of the curvature. That R30 there. Let me try sketching this. But that will take me some time. We have a curvature looking like this. And then our end, instead of projection, you see, when the arrow is pointing right, we flip it so that it points, not pointing right. The view is going to be opposite direction. So our front is going to be, with respect to that arrow, the arrow is pointing left. So our view in third angle projection is going to be in the opposite direction to the arrow. Arrow points left, view goes to the right. End view is going to be on the left of the end of the front view because this arrow is pointing right. Arrow points right, view goes to the left. Our plan, arrow points down, view goes up. So if you know the distances, length, width, and height, you know this is going to be our length, this is going to be our height, it's going to be our width, height, length, width. You make the boxes, and then we can start talking about the drawing. Now, here we talk about the section of view. In the picture I sent, there's no proper indication of where the section of view is going to be drawn with respect to. So I'll put it here. I want the section of view to be right here. Don't know if we can make it a bit curved, but yeah, let's just supposed to actually follow this curve. I'll remove this E just so that I can show you where the end is going to, where the section of view is going to point. So it will be X and X. So this line that looks like a center line is showing us the point where we're going to cut the shape line. In our drawing, let me just check if we have a circle. Yes, we do. There's a circle inside there. We'll assume that circle is a hole. I'll just put a small one to show us there's a circle. Imagine this was a very nice piece of bread that was baked by some special baker. Then we cut it at X. What are we going to see when we look in this view? That's what the section of view will give us. We'll start with the simple things. From this drawing, we have these straight edges. Remember, this is how our drawings are going to be positioned. So I'll sketch the front view that is sectioned. We're going to have a bottom part equal to the length. We're going to have a small 12 due to this. Remember, when we cut it, we're not seeing this part of the bread or part of the piece. We cut, and then we look at the remaining part with respect to the arrows. So this whole first part comes off. If I was to draw a small sketch of what it will look like after, it will be something like this. I'm looking at how people are looking at me. It looks like they're not with me. We have part like that, which ends on our curve. Then we have something like this. But yeah, I'll still put this just so you understand something. Then we have a hole to go that way. This is a simple sketch of how it will look. Not the perfect sketch, but yeah, just something to help you understand where we're going. So this is the part we're remaining with when we cut. You notice I'm not considering anything this side. It looks very similar, but I hope you can get the idea of what I'm talking about. So I want to draw this small part here that remains there. It's going to be 12. Like that. And then we have another part here which is also 12, if I can remember the dimensions clearly. So we have this part from here to there, all the way to the end, and then this part here also, which is similar to this region here. So you notice there's another 12. like that. And then on this one is where this circular part is coming, like that. It starts from somewhere there. The part here is straight, and then it joins like that. Because it's a section of view, this point, this here, is going to be this edge. This line is the line at the bottom. I'm sure you've heard of hidden details that show you something you cannot see, not so? When we're drawing our section of view, there are rarely any hidden details. So when you open this shape up, what was supposed to be a hidden detail earlier is just going to be a solid line because it's an edge, we can see it. And then something else we need to remember is that we have a circle here. It will be a hole that we can see. You notice in this drawing, I still draw the circular part and the straight part because of how we show in drawing that we have this particular feature. Whenever you see a certain triangular piece in this kind of fashion, it's usually referred to as a web. And this part in drawing is only put there for kind of support time. You have a structure, and then you are thinking if it remains alone like this, there's a possibility that it can be weak here. So you put this triangular piece to kind of show support. So when you have pieces like this, you're always going to show them as a separate piece because you're assuming the object is alone and then they just put it there. So they are two different materials. So it remains there and we're not going to section it. By section, I mean we're not going to show these lines. So this part here will have these hatchings. Because we're trying to show the person who's reading the drawing saying, when they were cutting this piece, or like we're imagining some special formed bread, when we cut here, this part where we've hatched is where the saw is going to cut through. You notice this part here is not cut. The one there, the one I've left here. The cutting blade does not pass through there, but it passes through this material and this material. Why are we not shading or hatching this web? It's because we want to show someone it's a different material. Right? It's only the web that we don't section. Yes. We avoid doing that for webs in drawing. We never. We do that if we have another material. For example, let's say we had, I wish, okay, maybe, although if we put a boat there, it will be a different case again. We also don't shade, we also don't section boats. So there are particular things in drawing. Boats, you know what a boat is, right? Yeah, your drawings don't get that complex, but yeah, if you have a boat in a drawing, let's say in that hole, there was some boat that was placed inside. You just draw it as it is, and then the section, the hatching lines won't cut through the boat. So it's a special part in drawing that we never section. But if it's a different material, like really different, for example, if we look at this stand, then we have a section view maybe through this. The different parts that are coming together here will have different lines of section. If I find the question, maybe I can explain it more properly. But yeah, it's possible that you can have two hatching lines. One in this direction and maybe another one in another direction like that. And that will indicate that this is not just something made up of one part. There are multiple parts coming together. Alternatively, that might show maybe another part of the same part, but yeah, these things are more easy to understand if you actually have a question. So that's our section of front. I won't really talk about the end because it will be very simple. The plan equally will be simple. That's how our section front will look like. Now what we'll do is, the same way we started our earlier drawing, we'll draw our rectangles for the front end plan and then add details to them. then finish up with the plan view. Remember, this time we're starting from the right part of the paper. So first thing you can check, like I said, you add your length and your width because you want to see if your front and your end can fit on the paper. It gives you 260. You check, can that 260 fit on your paper? Especially those who are using A4, you can see it can fit. So 260 is the distance of the front and the end together. It means there's no space in between, right? So if you want them to fit here, you really need to start from right there and then just move a small space and then put your end view. I'll show you what I mean even here. So my total drawing is something like 260 hundreds. I'm using distances that are different here. Let me just process everything. Okay. 260 by 2 before I make a mistake should be 510, 520. Those who are good with math, right? 260 multiplied by 2, 520. Okay, for me to still fit. But yeah, what I want to talk about is this. If you are drawing on a small piece of paper, remember we're going to have three views, a front, end, and plan. When I add this A on this W, it gives me the total space that my front and my end are going to occupy, right? So if you see that that distance you have, 260 is almost the same size as your paper. For example, in this gentleman's paper, this is 260. It's very big and it's almost the size of his paper. So what you have to do is you have to start very close to your border and then leave a small space between your front and your end, even just like 5 millimeters, very small one here, so that when you mark your width, it will still fit on your paper. You can see most of you are using A4. So for this drawing, you really need to start close to your body. Those with A3, you have enough space. For those with A4, you really need to start close to your border and then mark your 160, which is the length. So this is my length. I'll mark my height, which is 84. Something like that. The distances, your drawing will look very much bigger than this. After I have that box, I have those distances, I'll mark the box. Remember, we started with our front. Our goal is to have an end. So I need this to extend. And this is where now you need to just leave a small space. If you're using A4, just a small space, even just that close. That's why you start your end view from. We're together. Just a small space, then you draw a vertical line. For me, I have enough space. I'll put it very far away from me. So let's say I put it here. I need to get my width. Remember, it's W at the bottom of the end view. I mark it like that. I already have my height. This is my H. I marked it when making that box. Then, if you can remember, we said we need the 45-degree from our front view. This is our front view. We need to know where our plan is going to be. It's going to be on top. And that means the 45-degree line I was talking about should start from the rectangle for our front view and go like that. So that these lines meet there, and then give us our plan view distances. We are together up to there. I want to see someone drawing on a A4 reach this level. Yes, 160. 160. Where's the 160? 160. 160, not 260. 160. Yes. Wait. Show me 160. 0 to 16. It should come from here. Okay, mark that point. Then move a small space, mark 100. Yeah. Mark 100. Yeah, so it should be on 2. Yeah. Then form the boxes where the height. Yeah. When that line comes all the way here, form the boxes quick. Yes. Distance. You can get any distance, just to ensure that when you come and mark your 100, it will fit on the paper. So you can then just move here, mark a point there, and then mark 100. Make sense? It's the same as the previous one. We did that distance between the front and the end was any distance. So you can pick any distance as long as your end view is going to fit. This is where I'm starting from. This is the space and 100 feet. Okay. Now we want to make the 45-degree. 45-degree line. So make sure you reference to a horizontal line. That horizontal line can be your T-square, can be your set square, or it can be a line already on your drawing like I'm doing here. I always advise, if you're using a T-square, use the T-square so that all your lines are going to be parallel to each other. Not all your lines, but yeah, some lines that are supposed to be parallel. So this is our 45. I'll extend it enough. Now, the 45-degree line I drew is intersecting the two lines that were for my end view area. This is where my end view is going to be. Now, we're going to get horizontal lines that will go all the way and intersect with these two lines we started with for our front view area. At the end of the first step, you would have all the three areas where your front, end, and plan are supposed to be seen. Next, we just need to add some details. But before I add details, let me make sure at least we're on the same page with people. I hope the lines are not confusing, especially because we have another drawing that was there. Are they? They are. Okay. But it's fine. Line. This one. Maybe. Okay, anyone who has all the three areas. That's your height. The 45-degree line. No, don't focus on that one. This is what I'm saying. The lines are becoming confusing because of the area. So the areas, it's this part here, this part here. These are construction lines. Right? The outlines will come in blue. These are the parts I want you to have at the end. Anything that's not these lines is work from the previous drawing. So there are these lines. Please, outlines are going to be in blue. Eh? Everything that's there is, yes, all these are construction lines. Outlines are going to be in blue. The next thing we need to now start talking about are the distances. I already indicated earlier, this is 12. This is also 12. In the drawing, you can see, I don't know if they've given it very open, but yeah, they've given you a 24 and they've given you a 12. The one here is 12. And then they've given you the distance from this point to there, given as 24. So with these two distances, we can easily see that this part here is 12 millimeters and the one on top there is also 12 millimeters. So I'll start with those at the bottom there. And now I'll need to use this guy. A 12 like that, and another 12. Then I get these lines, take them all the way to the part where I'm going to have my end view. All these lines are in construction. Next, remember I want to come up with our section of front that I indicated there earlier. The next thing we need to have is our center point where we're supposed to stand and then draw our circle. We've been given a distance of 42. So we get 42 from this line that we earlier drew. If you check carefully on the drawing that we did, there's a 12 and then a 42. So we're getting from this point here, going up like that. This is where our center, this center is going to be. Then to know the distance from this point going towards this actual center, we refer to the 30 again. Remember I said when we have a radius, we can imagine it as a distance that can move. So it can move such that it becomes vertical, and it can also move again that it becomes horizontal. So now we'll get the 30 as a horizontal distance. Like that. We have a line, then we can use the 30. So this point here now gives me the center on which I can stand and draw a circle. That circle is again in construction, but if you have a compass like most of you do, which can make an outline, you can outline it in advance because you can see it's outlined there. Then I also have another circle that's inside. If we check carefully, they have not really given me the distance as as r something, or giving it to me as a diameter. If we check, there's a 30 that has been given there. And if we look at the way the 30 looks like, we should be able to understand that's a diameter, meaning our radius is 15. So we'll have to draw another circle. Okay, how do you determine the center? So knowing that we are working with, or our end goal is this, right? So we want to find basically it's like x and y coordinates of this point here. So if we check in the drawing, we've been given this 12. And if we look in this direction, that 12 represents this height that we earlier drew. And then we've been given a 42, which shows us a line on which the center is going to be. You agree with me? It's shown even in the drawing. So if I get the 12 and the 42, I know the distance starting from this corner point. This point here, it might be a bit tricky to understand that it's the same point as here, because when we cut it, there's really nothing here. Not so. Maybe that's where the confusion is coming from. But when we're in orthographic, when we're thinking of an orthographic projection, it's something that's flat. So distances can be in front and another one behind. But yeah, the point that's here is in the same line with an imaginary point that will be in the section plane. And that point is in line with the furthest point you can see. Now it's just that I can't perform magic and I hope I could just make things visual right here. But yeah, there's a point here which we know, a 12 for this, which is most likely a point that's there. Anyway, there's something I can still do. You can use a blue marker to just give you an idea. So inside here, this is what we'll be seeing. Yeah, something like that somewhere here. Then we'll have a hole there. This is where we've cut. So now at this point, these are connected. There's another point inside here. I'll put it in dotted lines. If we follow it, but then the drawing will become very complex. To connect to that, there's a point coming all the way behind here. That is the point we're referring to here. It's a point connected to this one. If you imagine this part on that side, there's a corner at the end here, somewhere here, that we're seeing there. That corner is on the same level as this point here. So when we're looking at the distances, we don't really mind what's here. We just focus on what's on this side because we know there's a relationship between everything. So there's a 12, a 42. And then if we want to know the distance from the end here, because we know this is a circular path, the radius of this can be imagined sometimes as a vertical distance or a horizontal distance. So we have 12 plus 42 and then a 30. I've even explained too much just for that. So that's where I was actually. So the radius of the inner circle hasn't been given explicitly. It's been given through a distance that is moving from one end to the other end. In this case, if we check, it's been given like this. They've shown to us like this. So now, as someone who knows what a circle is, you look at that. It's a distance from one end of the circle to another end of the circle, meaning it becomes your diameter. So the diameter of the inner circle is 30 because of that distance that I'm just from drawing. So if it's 30, it means the radius is 15. So you have that 15. I'm not too sure with the scale I used if I'll have that same exact circle. But yeah, I'll just draw a circle here. This circle is bigger than what you have. But yeah, it's just something to show you have a circle there. The scale I used won't allow me to have a proper circle there. But yeah, here you have a circle with a radius of 15. So the next thing that remains now is just drawing the outline for this section of front. Everything below here is a straight line, and I'll start outlining with that. And then this slanted part here is basically a tangent point to that. We don't need to construct it, it's just orthographic. Eh? But if you're actually wanting the most accurate point, you could use tangency concepts. In this case, I'll just find the point where they touch, like this, and I have the point. I'll outline this using my free hand, but for you, you need to use a compass. And then this circle also will need to be in outline. It will be smaller than this, and it will have a radius of 15. The next thing is drawing some hatching lines. How do we do that? We use a 45 set square. And then you can have help of a set square, another set square, or a ruler. Then you just start drawing them. When drawing them, your goal is to make them as even as possible. The spacing in between them shouldn't differ much. Yeah, at least something like that. As accurate as you can. There's always a trick to everything. You can figure out how you can make them accurate, like the spacing without measuring so much. Next, we're going to finish up our end view quickly and our plan. Our end view, notice when we draw a section view, we doesn't mean our end view will be something like this. We're going to draw the actual full one. The only thing we show in section is the section view. In this case, it was a section of front. The end and the plan are going to be drawn as they're supposed to be. So I'll look in our drawing here, what is going to be seen in our end view is this shape here, the web, and basically our curved part there. So distances, we need to have the distance for this part, that part, the internal part there, and the size of our web. Then we're done with our end view. If we check in our drawing, those distances are given. We have a 24 on the left and on the right. For these parts, we've been given the distance 52 in between there. And we've been given, sorry, I didn't notice this earlier. You see that there's a 10 there instead of a 12 for the part in the middle. What that means is this is 12, but this distance here is slightly smaller. We've got a difference between this surface and that surface of 2 millimeters. It's a very small difference, but if it's a part that will make a difference. So we'll include that on our drawing this side, meaning this is 10, this is a 12, meaning if we need a 12, we'll slightly lift this distance. You make that correction. So in your drawings, you can keep this 12 that you earlier drew, but just draw another 10. Let me do it the same as I've just guided you. If this is 12, we need a small 2 millimeters. So from this 12 we earlier drew, we'll subtract a small distance somewhere there. It might not even be very visible from afar. I will try to make it visible here. So there's a small difference like that. That's where our, it will be very small even on your paper, just 2 millimeter difference. So what that means is this, the hatching lines you are drawing and the section won't end there. Instead, they'll end on the 10. So they'll go all the way up to this other line. But we'll still keep that other line we drew earlier. It will still be helpful. This 12 will be what we use now when we're drawing our end view. So remember we said we have a 24. On this side, and on the other side, since I've marked these distances like this, I'm sure they'll be helpful in my plan. So I'll take them all the way up. And then I'll outline some shape that I have so far. I have the bottom parts. These are outlines now. The edges outside here are going to go up to the 12. And then it's only the part that's going to be inside, the one that is outlined here. That bottom line is the one we're going to outline in our ends like this. I hope you can see the difference now. So the part here is slightly lower than the ends there. Inside here it's 10. Out at the outer parts there, it's 12. If you look carefully in the drawing, there's a 10 that has been given here. And the 12 is outside there and there. So these parts here at the ends will be 12. Then in the middle there, it will be 10. Then because of how this drawing is, you can see there's a part that comes in and comes in there. We'll refer to our drawing. There should be some distances that can help us get that. If we check carefully, we can see we have a 12 millimeter distance that has been given to us. Some of these distances are not very visible, but they are visible, but they might appear not to be visible. There's a 12 that has been given here. I hope we can see it. That one tells us what distance we're supposed to have. You notice it's only given on one side, but because of this drawing, it's symmetrical. The parts, there are parts that you can say are the same. You will notice the 12, maybe it's given on the other parts. The 12 that we used here was given on this part. The 24 we got here and there was only given on this side, right? Are we following? Some distances are not given on all the parts they are appearing because they are similar. So you notice there's a 12 that has been given for this distance, but you won't see the same 12 being given again on that other part. They're assuming you can tell that it's symmetric. So I'll get that 12. I'll place it at this point here. I'll mark it here. And I'll mark it even on this other side. Immediately I do that, you notice I won't need to mark the distances in the middle. It's like they automatically will be included on my drawing. So I've marked the 12s. Let me just outline them so that you can see them. Not outline, but let me just make them a bit more visible. So this is where our 12 that I'm from marking is going to be. Like that. So now, with what I have, I know where I'll end if I was to draw an outline. Like that. Then on this other side, you shouldn't confuse it with this other line. It's this one here. And then how much I should go up, it was already shown in this drawing. It's ending there where our web is. It's also 12 here because of this 24. 24 minus that 12 automatically gives us that 12. We didn't subtract, but we just drew it in advance, so we know that our lines should come like that, like that. Then we'll have a straight line like this for this part here. The next thing that remains is drawing our web and just the rectangular part that shows our circular parts. So this drawing on the outer part is just looking like this. We'll have a web there. Then we'll show our circle. That's a hole using hidden details. If we check in our drawing, we've been given that the web has a thickness of 12. How do we locate the center? We can bisect. Or since we know that our width is 100, this distance is 100, you can just get 50. Go to where there's 50, like I would do here. Get 50. Then going in between the 50, mark a point there. This is the quickest way you could do it. I'll mark a point. And then on the right and the left, what's half of 12? 6. So 6 on the right, 6 on the left, and I have my web. So I'll do that. Roughly a distance of 6 on the left and the right. I have my web. I'll outline it directly just to be a bit faster. So this is total distance of 12 and the center there. Let me show the center for clarity. I'll just draw a construction line. So there's a 6 this side and a 6 on the left of that line. Then how do I get the position where I'll have my hidden details for my circle? That's a hole here. So I'll go to the top of the circle here, get a line that will go all the way that side, and at the bottom that will go all the way that side. Because we are shooting a square from this left side to the right side, we'll show hidden details like this. Hidden details are just dashed lines. So I have a dashed line. So this is our complete end view. We have this shape, an indication of where our circular part is going to be. By the way, I don't know how I'm getting this thing to work. This line that I earlier drew, you notice our circular part does not go the full width according to this drawing. It's not ending on this surface, it's ending on this one here and that one there. So we need to take note of that. change that I've made here, because of this space that's here being different from this one, this part that is circular here is not extending to the full length of our width. In short, the part that's there is not 100, it's smaller than 100. You can see there's a 76 there actually, because when you put it in the tray. So next, now we need to finish our plan view. We have some lines that can help us with the web and everything. It's just a matter of transferring them to this line and then taking them into our plan. So I'll do that. We could have measured all these distances again, but there's no need. If we are drawing orthographic drawings, we can just get them from our drawing and then transfer them to our plan like we are doing. With that done, we can also transfer those distances in our front view that we used into our plan. So the thickness of this circular part will be useful. I'll transfer it to the plan. The thickness of hole will also be required to be transferred there. So I'll take it up, then I'll extend them so that they start intersecting. So if we look now, the parts that we'll be outlining, let's say, for example, I want to locate the web. We know the web is formed by these two lines. So we'll follow them until when they turn. So we can easily see our web is this part that's here. We are just from indicating that these lines here are going to give us the thickness for that circular part. So we can quickly do this web here to guide us in our plan. You can start from anywhere. I've just selected to start from the web, like that. That's our web. Then we can also, for example, locate the circular part on top. We need to know where it's ending according to the end view. So it takes up this part. So we can follow this line and it shows us our circular part to take this space here. Remember, it should match even with the front view. These are the lines for the circular part. We follow the other line that we haven't used here. It shows us we're going to be here and there. Then we outline. The front part here will have a straight line because when we look on top, all these points here are going to be in the same line. At this part here, we'll have a straight line also because this line starts from here all the way up to there. So we'll mark it in outline like this, and even on the other side in outline. You can see this circular part here. If we look on top, we'll be in the same line with the line at the bottom here. So we'll continue an outline like that. And even on the other side, like that. I started with the web and the circular parts just so that you understand. If I draw them like this, it might look like we're drawing nothing. Remember, we started with the web, the circular part. Then as we start adding these other features, you see that they start kind of hiding the features that we knew. This part here is the actual circular part when we look at it from the top. Anything circular in orthographic just looks like it's a rectangle. The next thing that remains here, you can see there are those lines we haven't used. The ones that are here. We can draw hidden details for our hole that's going inside. One thing you notice when we're drawing these webs and the like, they are usually touching at a point kind of inside. You notice the point where the web is touching on the circle is different. So some people will be keen about that. You find in some books, instead of just ending the web here, they can go a step further and actually locate this point of tangency, which is somewhere here. I've located it with reference to where the line is touching here. So I get this point and mark a line going up. Don't want to mark it in full because it might confuse you with the other lines I've drawn. So the point where this web is touching is kind of somewhere here. So for other people who are really keen about showing this, they might actually show this point like this sign. I'll just draw a small arc. This arc can also be drawn by freehand. In your case, it should be just as small as possible. Usually like maybe a 3mm arc, it's usually difficult to draw that with a compass. So usually you're allowed to draw it using your freehand. And then you can make this straight like that. Once you decide to do that, it means the area line you drew for your circle here won't be needed. In this case, you are showing the full representation of how the web is attached onto this circular part. But even the first case is acceptable by most people. But if you want to be really rigid, this is how you're supposed to draw a web when it's attached to a circle. You find the point of tangency, the point where the line is touching the circular part. Take it all the way up like that. And then where it touches, you put small arcs using your free hand as small as possible, as you can get. And then join them to the lines coming from the web. Like this, you fully show now that that's a web. Next, you see that there's something we haven't yet drawn. This kind of slotted hole that is using up these two lines. It will be in hidden detail, so we will show some dashed lines. And it moves from the front all the way up to the back. It should be possible next time we meet to convert this orthographic to that isometric drawing. Everything in this drawing should make us able to draw an isometric drawing. So that's it about this question. Any questions from you people? I think most of the things are clear, aren't they? On which view?
This is the plan.
The plan, okay?
What are they trying to portray?
They're trying to show us the things we can't see when we look in the plan. For example, if you open this picture, when you look on top here,